I think it's recording now.
Yes, there is.
Cool. Oh my god, I have glasses like that. Do I look like a dork? Okay. So let's see if my VBox wants to work.
Do I need to download the VBox or thing, anything?
Oh no, that's just, I have a Mac
Okay.
and like DNA Masters for Windows or whatever.
Yeah.
So I had to download this to then put Windows on it to then use DNA Master.
Yes.
And it still doesn't like to work, so. You can see it, right? There's not like.
Yeah, I see your screen is loading. Oh, so DNA Master like the Microsoft software more than Mac, right?
Yeah.
Oh, that's why I'm seeing you running Microsoft in your Mac now.
Yeah, it's like a fake computer in my computer, I guess. I don't understand
So
technically.
it's like a virtual because I remember like I used a Mac before and I took IT and that IT just referred the Microsoft and I had to go like I go to Mason and use their virtual Microsoft like this.
For Stat 362, we had to use SAS, but SAS is like thousands of dollars, and I don't want to spend thousands of dollars, so I'd like go to the innovation like lab, the 300 lab,
Oh yeah.
and those computers had it, and so I'd be there like 10 p.m. like taking an exam. So,
Oh, they don't have kind of like because so I have like when I take it's not IT, it's like CDS and I have to use MATLAB, right? So I have to buy, but I don't buy. My professor give me like the website from Mason, go there and instead you stay like you said you stay in the school using the laptop, the computer, you can use from your own. Is it what you did?
no, so there's a something you can download called Octave. I think it's
I
called Octave, and it's just like MATLAB, but it's a bootleg and it's free.
Mm.
So it's like fake MATLAB, but it looks like MATLAB. So if you submit all your assignments, it's like MATLAB.
Yeah, I mean whatever work as long as free.
I like walk like 20 minutes to school because I don't want to pay for the expensive parking passes.
Oh,
I
your
park
house
in
near school?
RM. Hmm?
You are near school?
I'm like in Reston, but I
Oh,
park in Lot M by the field house
yeah.
because I don't want to spend more than $120 a semester on parking. That's just stupid.
Are you still in school or are you about to graduate?
I'm gonna be here one more semester, um, but I have like a lab on campus and I work on campus.
Yeah.
So I probably should have opened this before I started the thing. Oh wait, how do I see if like people are, like would be coming in? Because I don't
I
know
don't
how that
know.
works.
There's like Katricia say she's waiting and waiting for you to let her in.
Oh no, how do I do that? Oh
I
my god, this is bad. Okay, wait. Um, maybe if I stop sharing, it'll show me. Oh my god, yeah, I'm so sorry. I'm so sorry. I guess I can't like submit people or like admit people when I'm sharing my
no
screen.
no people in now.
Is
It's
she
free.
in?
Yeah,
Or
yeah. It's connecting.
cool.
Yeah.
Awesome. Okay. So da, da, da. Oh my god. You normally does not take this long to load. I swear to god.
Mhm. Maybe because your computer like loading so many jobs right now, like you playing Zoom and this.
That's fair. I'm not nice to my computer. I think I have like a bajillion tabs open right now. Oh, but the virtual box itself is like so slow. Like I like if I type something into like the internet, whatever, it takes like 20 seconds for it to show up.
Yeah.
How are you though?
Hmm? Oh, I'm doing okay. How are you?
I'm good.
Like, do you have, oh, I know, because you're holding the tutorial, so you kind of know what you're doing for project. But me, I don't really know.
Oh, dude, I don't want. I'm like doing a tutorial because like I learned how to use a thing and I thought it was really cool and I was like, oh, I want to show people like what if you want to do a project, right? But I'm not like a smart person.
Oh,
You
you
know
are.
what I mean? It's like
Based on like in class, you are. I can tell.
I appreciate that. I don't know. I wanted to do stuff with like the DQ phages, you know. Um,
I
like I
just
was
know
looking.
like the heat map and the how to say it, phylogenetic tree, a split tree. That's kind of cool because I love color and they show color.
Dude, oh my god, that's why I like the heat maps too. This is so great because not in the one I'm going to show you, but I asked the teacher to post a different one, um, a different tutorial I did where it shows you like a bunch of different color packages and all these cool different color palettes you can use.
Yeah.
It's great. And my favorite one, I don't know how to say it, it's like Viridis or something in R. And it looks like there's one that's like magma or like inferno and it goes from like fire colors kind of.
Oh, that would be good
It's
too. Yeah.
it's great. And then R has like its own stuff. Like the default heat map is like yellows and reds,
Yeah.
which is fine. But I don't know. I like the other one better.
I don't know. So as long as color, I got attracted to like making something colorful and yeah.
Dude, oh my god, I can show you. So there's the actually let me okay. So if you have your oh my god, I don't want to if you have your DNA master, uh, so like here's an older TuertoX I have. Um,
So for everything we are gonna do, everything would be in DNA master, right?
so all the like heat map stuff I do in R. If you, because I'm assuming everyone took 214.
Oh, I'm not.
Oh wait, have you? Are you a bio major?
No, I'm chemistry major.
Okay, well R is free. R Studio is free. R is fantastic. 214 is like the baby biostats, and at least people like have R from it, even if they literally taught you nothing. But they didn't
So
like suck.
you have to be in a class to use that, or is it free for every user?
Oh, it's just free. It's great.
Oh, so you're gonna show here too, right?
Oh yeah, I'm gonna show you R. You can literally just like type in like R download, R Studio download, and yeah. So anyway, oh you see here how I have like this, right? So this was I didn't want to call them like 33 and 76 because like order of stuff, and I was like, oh I don't know, but
Okay.
if you go to Pecan, I forgot, that's not the right website. Thanks Pecan. Is it pecan or pecan like the nut? I don't know.
I heard she uses say like pecan.
So if we go to anyway, here, right, it's a reverse gene. Wait, nope, this isn't the one we added. Where's the one we added? Oh my god.
So 26040.
This is the one we added.
That's one. Yeah.
Oh yeah.
33.
I don't know why it says. Oh cool, I guess it's. But so even though it's a reverse gene, so when you go into DNA master and you click insert, you can type in like the name. Like I just put 32 egg because I was like, I don't know what the order is gonna be, whatever, right? Because I
Yeah.
don't know things. Um, for the start and the stop, you have to pretend it's like a forward gene kind of. So even though like the start is technically like the bigger number, you put in the smaller number as a start. They do that part wrong, if that makes sense. So
Yeah.
like here, even though the start is 26324, you would put in the 26040 and the and then you hit reverse, and then you can put the name. Can you put like, does that work? Would it let you do that?
Let's see.
Yeah, okay.
Right.
And the new genes, like the ones we added, are already in Pecan, but if you wanted to find them and they were like weren't in Pecan yet, what I did is I went on like a Famerator, and like in the map you can see like, oh, we don't have this one, but like everyone else in CZ2 has it. So then I just looked up those sequences, I looked up the stop there, and then using the stop from there, you can like find the gene, and then you can like tell DNA master like, hey, this is where it is. If that makes sense.
Yeah.
But all you really have to remember is insert and then put it in the smallest to biggest order, even if it's a reverse gene.
Okay. Yes, I got it. Thank you.
So I should probably check to see if there's more people, right? Nope, that's okay. A little sad. Okay. So what it's like, anyway, what I wanted to do for the tutorial, which, wait, hold up, I want to pull up my thing where I said what I wanted to do, because I totally forgot to write that down. I think first I just want to show you how to like use the genome manager and the genome comparison tools, and then from there, like you can make like tree literally like by pressing one button, DNA master. Like there's other ways to do it. They have nicer, fancier ways, but you can like just, you know.
Yeah, just show us. That's fine.
So what was I gonna? So, all right. DNA master. Okay, and then Excel. Oh yeah, just formatting so it's easy to import. Blah 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 blah. Okay. So.
Is it okay if you share screen too?
Hmm? Yeah, go ahead.
Never mind. No. You share screen because you did it. It's fine. You share now.
Okay, cool. So if you go to tools and then you go to the genome manager, right? So like you can go to retrieve and then fetch by accession. And I think, I don't know if this is like the way you always do it, but it's just like the easiest way, I think. So like, for example, if I was looking for factor, phage, corgi, right? If it loads. Right, you can pull it up and then you can keep in mind. And then what other ones do I want to put? I forgot the names of them. I wrote them down. Okay. There's also, oh yeah, and if you want to do these like along, like I set it up so it's like all the FE phages, it's like looking at those. So you can make like a real heat map. It's just not for DQ, it's for FE. So Idaho, why noises?
So what you're doing now is you adding the subcluster into the group for us to analyze.
So this is like, I'm just like the genome manager, I'm just kind of like putting them in like the manager so I can like copy them or whatever, or I don't know, but I like putting it on the clipboard and then from the clipboard putting it into the genome comparison thing because I'm too lazy to click, but it just puts it in your manager, if that makes sense. Words are hard. Okay. The other FE pages are. So I think there's like 6 FE pages. And one of them isn't like in NCBI, I think. It's like Yazru or something. Which is kind of, oh, nope, not what I wanted to do. Okay. That noise is kind of annoying. Okay. But anyway, so these are the ones I got from NCBI. So I do save in local database and then fetch by accession. And then it takes a while. But let me show you the, nope, won't let me. Well, one of them isn't in NCBI. Like if you look for it, it doesn't come up. And it's like Yazru, like Y-A-Z-R-U. So I downloaded the FASTA, and then there's a way to like take that and then put it in your genome manager, like add it to the local database. So like you'd have to do that with TuertoX and like Chisana Kitsune, if that makes sense.
A little bit.
I'll show you. It's just like this takes forever to load.
Oh, I didn't read the rubric for the project. So you choose a type of project you want to do. Then you have to choose a type of like genome you want to work on, right?
Yeah, I think she said she prefers if we use the phages that we looked at, but I don't know. I thought DQ was cool, and then do you remember when they were talking about like the longest Gordonia, or like how there's a huge range of genome size in Gordonia phages? Oh, well, anyway, the DX phages have like 130,000 base pairs or something like that, and they're the most closely related cluster to DQ phages. I thought that was kind of cool. They're also, if you look at like the pictures of them, they look like myoviridae instead of cycloviridae, or I don't know how to pronounce words, which is same thing with like the DX phages. You know, they got like the tails look shorter and less bendy. I thought that was kind of cool. And then they have some of their like tail proteins in common too. So I don't know. It looked fun.
Seems fun.
If you want though, I could like give you the stuff I have for that if you want to do that for your project. Cause I don't know, I had a couple ideas.
Honestly, right now, hopefully I can get something from your tutorial and like kind of brainstorm with what I'm gonna do because right now my project is just blank. Like I don't really know. I just know that I want to do heat map or the split tree. That's the two things interesting. But like hopefully from learn from you so I can decide like oh I use this and then I'm gonna focus on this kind of genome.
Right.
Yeah.
I'm not gonna. I downloaded Split Tree and I don't know how to use it, so you're gonna have to do that one on your own. But I know you can make dendrograms and phyllo trees and all that stuff in R too. So it's like if you actually I have no idea if Split's tree uses the same.
But you know the heat map, right?
Oh yeah, heatmap. Okay.
I
So
mean like I between either of them, so maybe I can choose the easy path, like the heat map.
heatmap is so easy. It's like literally a few lines of code and it's just okay. So any hoodle, I fetched by accession and okay, well there's a bunch of them here because I kept doing it when I was like trying to plan this, but if I want to put them on my clipboard because I feel like that makes things easier, you just, oh my god, I downloaded these so many times.
That's why it takes long to loading.
Maybe. But so there's one more FE phage, and that's I should still have it. So it's this one, and I got that from Phages DB. And then you like auto annotate, and then I'm not gonna wait for that to happen because that takes time. I just gonna take the one I already have. Okay. Oh my god, did I not save it? Oh my god, why do I make my life harder for myself? That's the question. Sorry, this is gonna be such a boring recording if people are looking for it. They're gonna be like, when is it actually gonna start? It's like,
No, it's fine. Like, I'm really right now pay attention on what you do because like I'm not really familiar with this software.
right. I don't know. I think I tried like looking online and like some stuff was helpful. Like there's like a SEA-PHAGES website where people post questions,
Mhm.
and like most of the questions I had were answered there. Okay. And it's kind of dumb that this is taking so long because I on purpose chose FE-phages because they're so small. They have like 23 genes.
Oh, so you're gonna do on something bigger?
Oh no, I just mean like for like the whole like tutorial thing. I was like, oh my god, they're so small. This is gonna like not take a long time because it's like 15,000 base pairs. But no,
No, it's more than you
no,
expect.
computers still hate me. It's whatever.
No, that's the same thing whenever I do with DNA master. Like usually I let it like last time or the first time when I auto like annotate it, takes so long. And then I let it like overnight but it doesn't work. And then fine, log out.
I'm just like so happy that she actually posted like the blasted genomes because my blast like it'll like work and then it just will stop working. It'll go
Yeah.
to like 28% and then it's like, nah, we're done. It's like, great, thanks. Anyway, so once you have your thing, right, you can go to genome. Wait, where is it? Oh yeah, sorry, genome add to database. And then that puts it like in your genome manager. So going back to here. Ah. Oh, it's here. Just kidding. And then you can add it to your clipboard. So that's how you get it. And if it's not in NCBI, you
Okay.
literally just add to database. So like
Mhm.
that's what I did for some of the. I think these were actually. I think this was a mycobacteriophage. I think this was a gorgoniophage, but I don't remember. Any hoodle. So I just put them in my clipboard because then that way, if like I want to use them again, it's already there. But any hoodle, important part, genome comparison manual, and then see like you can choose them from here, or you can just hit clipboard, and then they'll pop up. See, look how small they are. Look how small. Isn't that kind of cute? And one of them's named Corgi. I thought that was kind of cute too. Anyway, and then you just hit analyze, and it'll give you a bunch of stuff once it's done. Which, oh my god, this takes
Oh,
so long.
is it okay if I run quick to help my father, then I'll be back?
Oh yeah, no, of course. Katrina, are you there?
Hi, yes, I'm here. I'm just like
Hello.
listening.
Sorry, I was like,
Yeah,
but
I'm here.
hi,
Thank
I'm
you for
sorry
doing
this is
this.
so
It's
long.
interesting.
Oh, no problem. I just really like colors, and it makes
Oh, yeah, I think I came on earlier when you were initially saying that about the heat map, right?
colors. Also, it got really warm, and I'm wearing a cardigan. And I put my cardigan. At least it's working. So there's that. But also, so annoying thing, right? So because I have it on a virtual box, I don't have Excel on my virtual machine. So when
Uh-huh.
it gave me the results, I had to like hand copy them into Excel. Because also like I don't know why, but it won't work with like the, even when I like pair it like both ways or whatever with my Mac. I don't know what it's called. But the like bi-directional like copying and pasting like that clipboard or whatever just doesn't work. So I was just like
What?
typing in the numbers.
You want to copy to Excel?
Oh, so DNA Master lets you export to Excel. So like if you have your Excel on your thing, it's fine. But if I try it on my virtual machine, it's like, you don't have that application. And I'm like, yeah, you're right, I don't, not on here.
In the virtual machine, like, can you log into like your Google Slide or your like 365 Excel? So like because you're using two different ecosystem because you are in like the virtual Microsoft and then you have to copy to your room map. What about you use the virtual Excel, like you go to the website, log into your online Excel and then directly like export from them? Is it okay?
I don't know how computers work. I'm gonna be
Because
honest.
last time I had the same issue too. Like it's really difficult to like export or like copy from the virtual to my real Mac. So I open my Google Slide in that virtual web
Oh my
to
god,
like
that's so
use
much
everything in
smarter.
one setting.
That's so much smarter. I can't even, I should have asked you. I can't even get copy and paste to work within the machine. I'll try to like copy and paste like a URL. Like, nope, that's not working. Thanks. All right, anyway. So, oh yeah, the things you care about. Okay, there's other cool things, but like this is a synteny map. I don't know. But pairwise summaries is what we care about. And then you can go to up here, average nucleotide identity, and then it gives you the ANI data. And then see here, this is where I'd be like,
Mm.
otherwise that button would use Excel, I'm assuming, or make an Excel file. But yeah. And then you can also go to like shared or open reading frames or whatever, and then it gives you that data too. And now I can finally stop using DNA Master and just use Excel. Okay. Do I have it in my recent files? Oh, yay, cool. All right. So this is the data from DNA Master on the shared open reading frames. And then for like the calculating the gene content similarity, it's just, this is the example. So like you take the numbers they have in common, divide it by the number of genes in one, and then the other, and then divide by 2.
Okay, I will follow.
Oh wait, I should write things down.
Oh, give me a second. Sorry again.
Oh, sorry. The formula I think is also in something she gives us, but what if I? Okay, it's like so it's like you have one phage. So if you have 2 phages, right, and they have a shared number of hands between them, you have the average the amount of shared FAMs divided by the number of FAMs in one,
Okay.
plus the number of shared FAMs divided by the number of FAMs in phage 2, and then you divide that by 2. So if you have your thing in Excel like this, though, you can just like, I wrote this here, just type equals, and then you can just like drag it. So,
Yeah.
I mean, that'll be in the recording, blah, blah, blah. Anyway. And then this is the ANI data, I think. Does that look right? I don't know. And then, oh yeah, for then the gene content dissimilarity, that's literally just 1 minus the GCS. So do you remember when they're talking about dissimilarity in like the Gordonia paper? Like that graph where it's like, and with cyanobacteria, it's like,
Yeah, like a smooth drop, right?
yeah, anyway, those graphs were looking at dissimilarity. So like the ones at the top, those were 100% like dissimilar. That means they have like nothing in common.
Okay.
And then at that drop, it's like the ones that had more in common.
Oh, so the drop meaning more common, and then the plateau, like almost like horizontal, will be like different, right?
Or the ones that are like, so they were arranged in order of how like dissimilar they were.
Okay.
If it's up here, that means 100%, which means nothing in common. And if it's 1, that means they have everything in common.
Okay.
Does that make sense?
Yes.
So if this is our GCS, like how similar they are, how dissimilar they are, it's just 1 minus that. I'm pretty sure. Like that's what they said in the, do I have open?
So Lulu, for you labeled it gene content final. Was that just from the formula that you talked about on the other sheet?
Oh no, I just have it like that.
Or
So
is
when I
that
put it into R, because I like wrote all this stuff here. Does that make sense? Like, so
so like
here,
okay, on the tab you're on right now, the second section, which is from the formula, that's the same as the third tab?
oh yeah, no. So this was just to show you like how to calculate it. So like,
Yeah.
you see how I have the different phages here, and then like the shared FAMs. What I did here was I put like Corgi, right, has 26 open reading frames, and then Idaho is 22, Y2 is 22, Noe is 23, Blue Feather is 25, Yabru is 23. So that makes it easier to calculate. So like,
Yeah.
for example, like this one, right? This would be Corgi and Y2, I think. So what it says
Yeah.
here is, up here I have how many FAMs they have in common, right? Which in this case is 16. And then when I come down here, it's saying 16 divided by 26 plus 16 divided by 22, and then that divided by 2.
Okay. And then what is the third tab? Just like a different arrangement of that, or it's something totally different?
Oh, I think I just copy pasted the values.
Okay, yeah.
This is just to show you that like an easy Excel way to calculate it, I guess.
Yeah.
And then GCD is just 1 minus that. And then ANIs we got from the DNA master.
Okay.
So I
you.
just want to verify again. So the information data we got from DNA master either ANI and
The shared open reading frames.
and then yeah, got it.
Cool.
Cool.
I don't know if I'm doing a good job explaining. I'm not a
No, you're good. You're good.
sure. Anyway, moving on. So, Katrina, are you a bio major? Like, have you taken 214?
No. So I'm like a non-degree student. I'm kind of just taking this class because it sounded interesting, and I took genetics as a prereq like for grad school with Dr. Shearer. So I'm kind of just like along for the ride here. But I mean, I want to do something somewhat interesting within the realm of what I can possibly do, like personally. So that's why I'm just here to see like if this is beyond what I'm capable of or not. But you're doing a good job of explaining, so thank you.
Oh, yay, I'm glad. Well, R is great. Our studio makes it even easier. Look at that. Look how nice that is. Well, okay, it looks really dumb right now because I collapsed it. But anyway, so once you have your like stuff in Excel, I just have it like this, and then like whoop, this because I think it's easier like to import it. Because then when I show you that, like if I show you like put it in like this, then in the tutorial, like you can just copy paste the code and it'll do the thing I told it to do, you know? Ignore me. Don't listen to the words I'm saying. Okay. RStudio, okay. So the first thing is importing data, right? So in my Excel file, I have the gene content similarity, the average nucleotide identity, and then the dissimilarity. And those are sheets 3, 4, and 5. So here I'm saying, well, first you have to, by the way, okay, so if you just get R or whatever, you're not gonna have like this package already. You have to do install packages, and then you write open XLSX, and then you put that. But I already have it. So since I already have it, I just need to say library. But you have to do install in library if you don't have it yet. You can Google how to do that because I don't think I explained that well, but ignore that. Okay. So once you have this package, it lets you, it's like an easy way to take in Excel files basically. So this part, what it's saying is, here's where the file is. So like in a Mac, at least you can just do like I don't know what that squiggle is called, the squiggle, and then slash, and then you just put your file like where it is. You don't have to put like user whatever or whatever. That's not relevant, ignore me. But and then I'm saying I have column names, and then column names, and then I have row names, and then these are the sheets to get it from. Does that make sense?
Yeah. Mm-hmm.
And then for the heat map thing.
Question. So for this sheet, you have to type exactly like you're typing now in your R Studio.
Well, this will be different for you because this is like the file path on your computer.
So are you typing or you click somewhere to get the link?
I'm typing. Sorry, I just did this ahead of time because I was like, oh, I probably should go fast because I know I'm going to take forever. But like, I don't know. But yeah, like it's like, you know, just typing. Oh yeah, and so with R, you use like Option Enter to like run something.
So there's no tab that like you can like click on and then how to say export or like link or something?
I think there probably is an import wizard, but this is just easier. It's just like one line of stuff. But okay, if she posts the tutorial I made, I literally made it so it's fill in the blank. So like, and you can either put it in manually or through Excel. So the tutorial I made for the other one is like super, super easy, like just plug and chug and it'll do it for you. So hopefully she posts that, or I can email it to you. But any hoodle, what this is saying is, first I'm importing the file, right? And then for the heat map to work, you have to have your file in like a matrix. So then I'm saying like make it a matrix. And then what this arrow means is I'm assigning that like matrix to GCS, or I think that's the name of it or whatever. If that makes sense. I'm not a computer person, so I'm definitely not using the right words when I say things. But basically I'm just saying, this is a matrix with the gene content similarity. And then this one has the ANI, and this one is the dissimilarity. Does that make sense? There's a PDF online you can download of something called R in Action. It was like a textbook we used for Stat 362, but it's free. You can get it online for free. And it explains R super easy. Like they go in real detail about like everything, and like it's like a R for Dummies book, which was perfect for me.
Can you type the name in here?
Yeah. Maybe I have it on my computer. This is what it looks like. If it's not legally on the internet, there you can go to gen.lib.rus and you can download it from there. Probably shouldn't. I don't know. I'm not showing this recording to anyone who'd be mad at me for that. Oh, there we go. Yeah. So this is R in Action.
Got you.
It's great. And so then they have like the whole like chapter, which is like getting stuff into R. And I can also, if you email me, I can send you like my PowerPoints from like Stat 362. I save everything on my computer, which is probably why I have no space.
Yeah, actually, yeah, I will write an email. Also later, can you share the Excel too? So like, we can look over the Excel you're doing now and work.
Yeah, sure. If you want, I can just email you guys this tutorial instead of the other one. The other one just has like the plug and chug and then more colors.
I mean, like what? Can you just email both? So we just, if we have time, we watch both. If not, this is the main source to watch.
Yeah. Okay, so, oh no, did it open all my things? No, it didn't. Cool. All right. So now that I have those for the heat maps, so this is just a few possible color things you can do. So the default heat map looks like this. Oh yeah, these are also packages that you'll have to do install.packages, and then this to get the colors that I'm going to show you, but this is just like base R. So it's like, you don't have to download anything. It's just there. So like the function to make a heat map is literally just, it's literally just heat map. And then you put in whatever data, right? But since ours is like in that like symmetrical format, you know that, I don't know how to describe it because I don't know things. But you know how it's like symmetrical, like along the diagonal?
Yeah.
You know what I mean? So if you don't specify that it's symmetrical, you get like this. Which like you can see, like even though this is like, I don't know why it does this because I don't know things, but you know how it should be 1 to like 1, 1, 1, 1, 1, 1. But here you can see like some are darker than others. I don't know why, but if you don't specify that it's symmetrical, it does that. But if you do specify it, you get like the correct thing, if that makes sense.
How different from the first heat map and this heat map?
So like look at like the diagonal, right? So I don't know like the actual reason. This is just what like I noticed. You should ask the teacher because she's smart. But like you know how on the diagonal it should all be like 1, 1, 1, 1, 1, because you know, blue feather is blue feather. It should be 100% identity, right? Because it's the same thing. So then it should be like all like the darkest value along the diagonal, right?
Yeah.
But I don't know why, but if you don't specify that it's symmetrical, it doesn't do that. So like, it's all different. I don't know why. I just know that it looks dumb and wrong.
I just feel like your map is just switching. So first, it's like the more dark, it's like here, and then when you switch to the second one, it's here.
So do you see how like, you remember how I was talking about the diagonal thing? So if you look at these two boxes, right? This one is like not the same color as this one.
Yes.
But it should be because it should be 1. These should all be 1. Because corgi is corgi. It should be like 100% similar. You know? But then for some reason it's not like that. So I don't know. You have to specify it's symmetrical, but I don't know why.
Makes sense. I see the color difference.
Oh yeah, then this is like just the default colors. So like if you like these, you don't have to do any extra work. And look, they even give you the dendrogram. Isn't that so nice? It's literally just like, what, 7 letters? That'd be really embarrassing if it wasn't 7 letters and I couldn't count. But yeah, that's it. That's literally it.
So I don't know if you know the answer to this, but so like for example, like the heat maps that we've seen in articles or just like in general, like would you say this is probably using R as well, or it just depends? Like, are you aware of other, like I'm assuming you could do the same thing like in a different language in theory? Like, I don't know if you know anything about that. Or if that makes sense as a question.
No, I got you. No, it's like I don't know computers. I don't know anything. Like I don't know Python or Java or anything useful. I just know R and kind of SAS, but I didn't like it and it's expensive and the online student version sucks. You can't even make pie charts. That's like a second grade thing. Why can't you make pie charts in online SAS? If anyone's listening and knows the answer to this, why can't you do that? And just Not,
Okay.
not
Yeah, so I
really.
guess this is like the easiest, like most affordable and accessible manner, it sounds like.
Yeah, look, it's just like literally 7 letters.
Yeah.
Fantastic.
Okay.
If you want to see what they used, they should say in the paper. So if they don't say underneath the like figure, go to materials and methods,
Yeah.
or like it should be there somewhere. I just know somewhere there it will be there.
Yeah, okay, that makes sense.
So related to this, like in the article, it's really complicated and it remind me about what I saw my friend did in the CDS class. So I feel like to do that level, it's not about software. It's more about like you have to take a class to know how to do it.
I didn't learn any of this though in a class. Like our like Stat 362 is great for learning like basic how to get stuff in there and like how to make, like box plots and how to
Yeah.
do a t-test.
But I mean like the figure Katrina asked for in the article to do in that level, I feel like you have to spend hour to watch YouTube or at least you take a class because I know my friend took like CDS class and he using data to draw something like that.
It's pretty cool.
Yeah,
Um,
but it's
Well, I mean, the heat map, I mean, specifically the heat map in the first article, like, I was just thinking, like, that one of the main differences is it just had so many, like, data points. I think that's kind of why it looks different.
like this has 6. That one had like what, 627? Was it?
probably yeah.
627, right? I don't know. I don't remember numbers, but any hoodle. This is like the default colors. I think they're kind of boring. In base R, in R, if you want to see what color, you do col equals and then whatever. And so R has some things like already made up for you. So like they have like heat colors. This is what it looks like. The only thing about like this one is you have to specify in reverse order, because if you don't do it in reverse order, it looks like this.
Uh-oh.
And it's like the opposite of what I want, It's like I want the big numbers to be read. So if you specify, what did I do? Excuse me, sir. What is happening? Hold the phone. Oh no, it is working. I don't know why I was doing that. Anyway, so this is like another color option. The package Veritas has like, I think it only has like 4 things, but it's really cool. Like they have really cool colors. I think it's great. Like this one, look at that. Look how cool that is. Right? Right?
Yeah, it looks nice. Like if you like more cold shades like blue or green, like how do you type?
Oh yeah, I mean you can like, base art has other colors, Veritas has other colors, like they have, I don't even know if that's how you're supposed to say it. I don't know, man. But yep.
Oh, yeah, it looks
That's an
cool.
option. I know. It just has a lot of cool ones. And the nice thing about it is you can have as many like genomes as you want with the next one I'm going to show you. So it's called Brewer Pal. So the package is called Our Color Brewer, and it has some cool stuff, but the problem is it's not like, I don't know how to say it. It's not like continuous. Maybe that's what it is. But it's like each palette has a certain number of colors you can use. So like if you have like 4 or 5 genomes, you're good to use it. Like if you're just looking at DQ phages, like DQ only has 4 phages. So you could totally use Brewer Pal. But they have some other colors too. Like this one's like a blue one. And the thing is, if you want to know how many colors are in a certain palette, you can do brewer palette info, and it shows you like what it is. So this is like brown, blue, and green, which sounds disgusting as like a color thing. Why would you do that, right? Like, oh my god, I want to see what it actually looks like.
Yeah.
That's horrible. Why would you ever do that?
It definitely is a no.
It's a no from me. But anyway, so like you can see how many the maximum amount of colors. You don't want to choose something that says qual. It's like qualitative. It's not like an actual like oh, it goes from like red to like green. It's just a bunch of random colors in a palette. Like if you wanted to like do a bar graph or something, I guess. Like pastel is a bunch of pastel colors. Great, but they're not in like any particular order, you know? But these ones are good. I thought this was cool. They also tell you like if someone's colorblind if they can still see it. I thought that was nice. I'm like, that's a nice thing. I like that. But they have some cool ones like whoop. Again, it only works if you have like if you have 5 genomes, you can do the ones that have 11 colors, I think. But if you have 4 genomes, you can only do up to the ones that have like 9. Because I think you have 7 different colors. I wrote it down somewhere. But if you're looking at DQ phages, like if that's what you want to do for your project, you're good to use PreRepal. I don't know, is there a color you guys want to do? Is there one of these you want to see? I don't know if you can see this. I kind of like, I feel like in terms of usefulness, but literally I think that's the default heat colors. Never mind, that's stupid. What about yellow? This is so, I'm wasting time. This is being recorded. I shouldn't be like, but it's like the color part, right? That's like,
yeah, this color look nice.
Yeah, so if like you wanted to like do the DQ phages for your project, like you were saying, like ideas, right? If you wanted to look at how like similar DQ phages were, which is actually cool because one of them is super weird.
Oh, so if I'm gonna do heat map, and then first you have to choose a phage, right?
So yeah, you choose like which phages you want to look at.
So you choose, let's say like we doing, I'm just a sample. So let's say we in class we do TuertoX. So like I choose TuertoX, and then you will choose a I don't know the name of like bio. So you choose a phage, then you choose like like eBird, and then highlight 20. So what does it call?
You mean like the other phages?
Like first I choose TuertoX phage, and then inside that, what do you choose?
So for like the heat map, if you have TuertoX, right, and then you can look at how related is it to eBird versus how related is it to Sprouty and Soil Assassin. So like if it's more closely related to eBird, like for this palette, you'll get like the darker blue.
Sorry, if I ask this silly question, I kind of mess up all the definition. So eBird is another phage.
Yeah, yeah. So like when you look at do I have Famerator up? No, I don't.
So heat map just basically compare the similarity between phages, right?
Exactly,
Okay.
yeah. So there's like 2 ways to do it, from what I can tell, from the papers at least. So the first paper, when they looked at the heat map, they were using gene content. So that's like when we calculated the GCS, where that was like with the dividing the FAMs by the total FAMs, and then blah, 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 blah. That formula is in one of the papers I know. Because they have the formula for the dissimilarity. So it's like 1 minus bunch of gibberish. That bunch of gibberish is the similarity, if that makes sense. I think it's at the end of the Gordonia paper.
Can I go by the text, how to say, like the order? So phage would be the biggest, and then inside of phage you have cluster, and then inside cluster you have subcluster, right?
So a phage is like, that's like the actual virus.
Okay.
So like clusters are like groupings of the phages. So it's like, oh, these ones are cousins. These ones are like brothers. Like Sprouty and Tuerto, they could be brothers. But maybe like Tuerto and Chisano Kitsune are like distant cousins. And then you get to see that with the like trees and stuff. Or like the maps, that shows you how similar they are. So like if you wanted to for your project to do the DQ cluster, it'd actually be like really easy because there's only 4 of them. But it'd be cool to talk about one of them, GMA6, I think. Super weird. It's like really not closely related to the other. Well, it's kind of closely related to the other ones, but like it's got a lot of orphans. And I think it shows up in the Gordonia paper, but they call it a singleton. So in 2017, it was considered a singleton, I guess, unless I got that wrong. But it's so weird, right? So I think it'd be cool to see like on a heat map, like how related it is to the other ones compared to the other DQ phages. I don't know. I can email you about that if you want, but
Yeah.
any hoodle. What?
On that note, like, I feel like I don't fully understand like what is there like a specific formula or something that would determine like, okay, it's in a cluster or subcluster versus a singleton, like kind of like what you just said? Or is
So
that more like people are continuously submitting like new pages, and then like as that happens, I guess the CFAMS people are like, okay, actually there's now like this, like, does anyone know the answer to that?
I have no idea. That'd be a cool question for the teacher. But I know from the
Yeah.
papers that for like the mycobacterium pages, they were looking at if they have more than like 50% gene similarity, then they're a cluster. I think that's what it said. Like 50% for the mycobacterium. I think the Gordonia, it might have been like 35%, maybe. I don't remember exactly. You can go look
Yeah.
at the papers.
Okay.
But I'm pretty sure about the mycobacteria one. But because you're the Gordoni ones, the paper is like, these guys are weird. It's not as
Yeah.
pretty and neat as the mycobacteriophages. But
And like, I mean, technically, like, regardless, it's like sort of, it's like a construct, sort of. Like, I mean, it's not like there's no evidence, but it's not as if like for the clusters.
like we're making the boxes that we're putting them in.
Yeah, I would say.
Yeah.
Anyway, back to your code.
Oh right, sorry. I'm so easily distracted too. I was
It's like a bad combo. I have a lot of random questions.
dude, I
I
know.
think you're about to say, like, you were saying there's 2 different ways. So you can do the heat map based on like gene content, and then also,
Right. So I'm so distracted. It's like yesterday I was talking about like ostriches, and then I was talking about my fear of ostriches, and then somehow I got to like dinosaurs and mosasaurs, and then something else. That's not even relevant. See what I'm saying? It's just tangents. I'm going on a tangent about tangents, and I need to get back to this. So, for example, this was our map based on nucleotide identity, right? ANI. But remember, we said like a bunch of different things. So, if I wanted to do it by gene content, which is what was in the Myco paper, the ANI heat map was in the Gordonia paper. I don't know why they chose either for either, but any hoodle. This is like what it looks like when you look at the FAMs, the gene content. I think this one's prettier. I think that, not that one, but it's kind of cool. You can see like this box. These ones look more related than these ones. I don't know.
So are we using still the same topography, like darker color will show more similarity in
Yeah. I'm going to show you in a second how to do legends for these. So I'm not going to lie though, I'm not a fan of Rupow. I think it's lame. No, not necessarily, but Fong, you said you like this one, right?
actually no.
No? Okay. I want to choose a Veritas package one because I think they're way cooler. What about, okay, what about that? I only know these four. I don't know if there are any other ones.
I think I like the third one, the previous one. Yeah. The mango. I call mango. No, magna.
I love mangoes. Okay, this one? Okay, and do you guys want to do gene content similar to ANI?
I feel like it was prettier with GCS, so that's fine.
I agree. Right. All right, so we're going to do it using this one. Okay, so then colors. I don't know why I had a whole section on colors. I just think that's like the most fun part, right? Whoa. Okay.
I also think this is the main thing too about heatmap.
Like, wow, like data visualization. That's what the cool kids do, am I right? Anyway, so this is our default one, right? But like, what if I want to add like titles, or like if you look at, like if we zoom in, you see how like the blue feather gets cut off? So you can either increase the margin, which I think is kind of annoying, or you can make the text smaller. I'd rather make the text smaller. So in your heat map, right, you say what your data is, you specify it's symmetrical. To make a title, you write main equals, and then in quotes you put the thing that I need to change now. Right? Put your title. CEX call, what this is saying. So CEX means like size in R. I don't know why. It stands for something, I don't know. But so what I'm saying is here I want the size of the text in the columns to be 0.9 and in the row as well. And then here's my colors. So that's what all those things mean. So now if you look, the text is smaller, it like fits in, and we have a title. Okay, and then here's the thing, like if you want to keep these, like that's all cool, but I kind of don't like them there. I want to get rid of them. I'd rather do it separately if I was making a dendrogram. So where is it? Okay, so here in the heat map thing, you can like tell them not to do like the whole ordering thing. And hypothetically, there's a way to just say, get rid of the dendrogram, which is like keep.dendro, I think, but it didn't work for me at all. Like it still stayed there. So the way to get around that is, you see how here, when I made this heat map, I called it X, right? The reason I did that is so that now I can go to the gene content similarity and change it. I change the order of it to match the order that they've done here. Because if you notice, this isn't the order the genomes were in before, right? Corgi, Idaho, Y2, blah, 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 blah. Here they changed it. They changed it to like make those dendrograms. They're like phyllo trees, right? So what I want to do is reorder them to be in this order so that even once I tell it not to do the dendrograms in the ordering, it's still like pretty like that. Does that make sense?
Yes.
Okay, so here what this means is I'm just ordering it. I'm telling it to order the like columns and the rows as they are there. So if we look at it now, but excuse me, sir. It should be ordered the other way. Did it do it, or am I stupid? Let's see if it works. I remember it worked at one point. Okay, what went wrong? Well, anyway, that's what happens when you don't order them right. Ha, okay. Okay, so right now, okay, cool. So yeah, right. Sorry, I think maybe clicking it twice messed it up. But now this here, where it says col v na, row v na, and then blah 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 blah. That's basically the thing that's telling it not to do the ordering and getting rid of the dendrograms on the side. We ordered it ourselves here. I don't know what I did before, but this is right. Use this. I'm gonna change the title. I don't want it to be the other one. So does that make sense? If it doesn't, you can literally just copy paste your stuff into here and it should work. Yay, right? I don't know. And then for legends, so in R, I don't think, in base R at least, I don't know how to make, or if you can make like a gradient legend, you know? If you can, I don't know how, but there's a package you can download called plot functions, which makes it like a lot nicer. Makes it really easy. So and someone's probably gonna watch this and be like, I know R better. Listen to them, because they probably do. Okay. So anyhoodle, here's my map, and then here is how to make a legend. So it's a gradient legend. Then for the smallest value, I'm putting the minimum gene content similarity that we saw, and then the maximum is the maximum, which is 1. And then I'm writing and specifying what colors we used. But for color, now it's color instead of COL. I don't know. Boop.
Oh.
But that's like so ugly, right? We don't want it to be so ugly. Like, look at that. It sucks, right? I can't even read the numbers. SMH. So then what you do, okay. So, and then if she posts the other one or I can email it to you, I explain what all the different things mean. Like with these. Like, okay. Like I explain, like, if you forget, like, what position and seg and all that means. So with this one, position, I'm specifying where it is. It's right now it's on, you know how it's like on the right? If you wanted it to be somewhere else, you could put a different number. So this is side 1 is like the bottom, 2 is like the left, 3 is the top, and right is 4. But the default's 4, so you don't have to write side equals 4. Position shows where on that axis it is. End seg means, so you know here how there's only one line in the middle?
Mm-hmm.
You can choose how many lines to put there. So like if I wanted like 5 divisions showing with 5 numbers in between, I could do that. I just wanted 2. I thought that looked nicer. Length, I made it longer because it's like kind of like stubby. I don't know. And then DEC is decimals, so I'm saying I only want it to 2 decimal places. Does that all make sense?
Yes.
Awesome. So if this isn't messed up, this should work. Also keeps giving me warning messages, but there's nothing wrong. I don't know why it's angry at me. I don't know. But yeah, so you see how it's like so much prettier now? Right? So much better. So gross before. And if you ever like want to look at, oops. Okay. If you ever like need help with something, you can always just like, there's like a help thing, or you could do like, and then type whatever you need help with, and then hit, and then enter, and it'll like bring up the help menu. Our studio is like, it's like supposed to be like dummy proofed, which is why it's so great for me. Anyway, so yeah, that's how you add a legend. And then, oh, I guess I made both of them here. But we already decided the ANI is ugly, so ignore that. But anyway, yes, that's how you make one. That's it. Do you guys want to see dendrograms?
Sure.
Cool. Okay. Well, only if you want to. I don't want to be like keeping you guys here. I just thought like while we're here, like, why not, right? I don't know. But
yeah, that's fine.
Awesome. That's exciting. Okay. So where did I do it? I don't know what in there is important. Okay. Okay, so for dendrograms, this is like I think this is just base R. No wait, is it? I think so. Okay. So once you have your like gene content similarity, this just changes like the margins. So par is like parameters, and in R you can change a bunch of stuff. Here I just changing the default margins. So it's the same thing with 1, 2, 3, 4 is the sides. So I made it really wide on the right side. Okay. So I should probably, I'm showing you guys, I should probably break this up. But anyway, this is how you calculate basically like what calculates the distance for you, because gene content dissimilarity is not equal to distance like on a phylogenetic tree, because like I don't know, you have to do something, but I know you can do something like there's different formulas for it. One of them involves like taking the natural log or something like that. I don't know math, but anyway, that calculates the distance in terms of like the evolutionary distance, I think, for like the gene based on the gene content similarity. And then this is clustering it, so H clust, and then as dendrogram is like saving that like in a form that we can make a dendrogram, if that makes sense. Too long didn't read, this is just formatting it for you, the data. Anyway, so then for type I put R, which is, well, you'll see, but let me just, so here is my thingy. It's like rectangular, right? Whoop, sorry. And the space on here. You see, like that stuff, like the thing. So this is if you wanted it to be like triangular. It's T instead of R. I think this is way uglier right now, but I'm like, I don't know, if you wanted it to make it look more like the split tree networks. I don't know if this is how those are made, but it probably looks more like it. I don't know. I don't like it. I think it's gross. And then it's horizontal, and then this takes away the root. at the bottom. Because I shouldn't even put it there because we don't know the last common ancestor or whatever, but whatever, I think it looks nicer. But yep, that's basically like the really basic base R one. If you want to make it pretty, and I know I keep saying download packages or install packages or whatever, there's this one called Ape, and that helps you make really pretty ones, like really pretty words are hard. Phylogenetic trees. I think I said that correctly. Anyway, so for this one, right? You still are doing the clustering and the distance and the scaling or whatever, but this time you write as.philo. This makes an unrooted tree, and then this one I put no margins because otherwise it could cut stuff off. I haven't really like explored this a ton yet, so I don't know all the stuff to make it nice. I know that you can offset the labels. So like them are spaced out. Not all together, but I don't know if I haven't figured out how to like do just specific ones yet. We'll see how that works out. I don't know. I don't know how to do things. And then you can also make like fans, which I think look super cool. Right? Doesn't that look cool?
Yes.
Right? Isn't that great? But anyway, there's a way to like color. So like with like colors, right? You could just say like you could do that, but hear me out, right? You know how some of these are different like clusters and stuff? What I was trying to do before that did not work because it messed it up. I don't know why. I have to figure out why. But I was trying to get it so that like the different clusters would be different colors. But I think maybe it's the order in which it's listed in, it wasn't working. I have to figure out how to make that work. Or maybe I won't and I'll just be lazy and leave it. I don't know. I'm not even sure I'm gonna use this. I'm very indecisive. I have no idea, you know? If you see anything in here that you wanna do, let me know and you can totally do it because I don't know, man. I'm all over the place. But imagine if that looked correct. Imagine if it was correctly labeled, how cool that would look.
Yeah.
Right? Whatever. Everything's fine. So that's my horrible tutorial for dendrograms because I don't really know what I'm doing with those. I don't know.
I think it's a really useful tutorial.
Oh yeah, I'm glad. Oh, this is, if you want to see a cool heat map, right? This is, so these here are the, do you remember I was talking about the DX phages? So these were the ones that are like the really big ones. Like, you know how like, they were like the Gordonia paper talked about the really, really small ones that only had like 17,000 base pairs, but they also said there was like ones with 130,000 base pairs. That's these ones.
To make this heat map, are you using the same step like you showed us previously?
Exactly the same steps.
It's just like we have more phage, right?
Yeah. And
okay.
like you guys have Excel on your computers. You can literally do it as whatever, you know?
It looks awesome. Yep.
Thanks. And then, oh, these are cool. These are singletons, but they're, if you look at, okay, so like here, Canter, that's a singleton. But look, Chisana Katsune, blah, blah, blah. Look how like it's not like it's not like obviously it's closely related, like something like in the same cluster, but look how much similarity it has with it. Isn't that kind of cool? I don't know. Oh yeah, and then this one here, that's the one that I was talking about it used to be a singleton. At least in the paper, they called it a singleton. Maybe it was a mistake. I don't know. Or maybe in 2017, they just didn't have DQ yet. I didn't see any DQ phages in the paper, except for this one. But like, look at that, right? You can see like how related like these ones are. These are the other 3 DQ phages, and then look at that. It's actually a very nice color. I like it, but you know, that ain't it, chief. You know, I should probably like turn this off, but oh, did I not put a legend? Or is it just like off the page? There it is. Wait, I don't know. This one has like 3 in the middle. I don't know. I'm just very enthusiastic about colors. I think it'd be really cool if like people like saw this and wanted to make a heat map, you know? Because look how cool those look, right? Oh, another crazy thing, right? These, the Visconti and Thoth. I don't know how you say that.
It's fine. Yeah.
Kind of sounds like if you said sauce, but with a lisp.
Right.
Right. These are mycobacteriophages. And what this like map is a blasted Chisana Kitsune and phages DB, and these were all the ones that return like an E value less than 10 to the negative 10. So like literally like Canter is a Brevibacterium phage, I think. Either Claus or Canter. I think it's Canter is like that's like I don't even know what that is. I don't even know what a Brevibacterium is or looks like. I don't know what that looks like, but it's like pretty closely related to it. And then these are mycobacteriophages that are like also like somewhat similar to it. And I thought that was cool. But yeah, Canter is a really cool one. There's a lot of genes or a lot of FAMs that are only in DQ phages and then also Canter. What's going on with that, right? I don't know. Yeah, I don't know. But I should probably stop this recording.